The spring of 1943 brought a pivotal moment in aerial warfare history, though few recognized its significance at the time. High above the French coastline near Dieppe, at an altitude where the air grows thin and cold, American fighter pilots were about to demonstrate a fundamental shift in how air superiority would be achieved. Major Donald Blakesley's hands controlled a machine that represented something entirely new in aviation combat philosophy, and within moments he would validate years of controversial design decisions. The Republic P-47. Thunderbolt had been the subject of considerable skepticism since its introduction to the European theatre. British pilots, accustomed to the elegant agility of their Spitfires, looked at the massive American fighter with undisguised disdain. Their nickname for it, 7-ton milk bottles, captured their assessment of its bulk and supposed unwieldiness. The aircraft was indeed enormous by contemporary standards, weighing more than twice what German pilots flew into combat. Everything about it seemed to violate the principles that had governed fighter design since the First World War. Yet Republic Aviation and the United States Army Air Forces had pursued a radically different vision, one based not on traditional notions of aerial combat elegance, but on the emerging realities of industrial warfare. Below Blakesley's aircraft, a German fighter emerged from the clouds. The Focke-Wulf 190 belonged to Jagdgeschwader 26 Schlageter, one of the Luftwaffe's most distinguished units. Its pilot likely felt confident in his mount, which represented the pinnacle of German aeronautical engineering and had proven superior to earlier Allied fighters in many respects. The FW-190 combined excellent performance with heavy armament, typically carrying two 20mm cannons along with lighter machine guns. German pilots had used these aircraft to inflict severe losses on Allied bomber formations and had bested many Allied fighters in individual combat. This particular pilot had no way of knowing that he was about to become a historical footnote, the first aerial victory for a fighter type that would fundamentally alter the air war over Europe. When Blakesley pressed his firing button at 300 yards distance, 8 Browning heavy machine guns responded simultaneously. Each weapon was capable of firing 800 rounds every minute under optimal conditions. The combined theoretical rate of fire exceeded 6,000 rounds per minute, creating a stream of half-inch diameter projectiles that filled the air between the two aircraft. The ammunition was a carefully designed mixture, primarily armor-piercing incendiary rounds that could penetrate metal and start fires, interspersed with tracer rounds that burned brightly to show where the bullets travelled. The visual effect was unlike anything previously seen in single-seat fighter combat. Rather than discrete flashes or individual projectiles, the P-47's guns created what appeared to be a solid beam of light reaching out toward the target. The Focke-Wulf disintegrated under this assault in a matter of seconds. The German fighter, despite its robust construction and the skill of its pilot, simply could not withstand the concentration of firepower directed at it. This destruction marked more than just one aircraft's loss or one pilot's victory. It represented the first combat confirmation of a new approach to aerial warfare, one that would prove decisive in the struggle for air superiority over Western Europe. The Americans had not attempted to build the most maneuverable fighter, or the fastest fighter, or even the most heavily armed fighter in traditional terms. Instead, they had created an airborne weapons platform designed to deliver overwhelming firepower through the application of industrial mass production capabilities. The path to this moment had been neither smooth nor straightforward. The 4th Fighter Group had flown its first operational mission with P-47s weeks earlier, on the 10th of March in 1943. That initial sortie over France had been plagued by problems that seemed to validate the skeptics' concerns. Radio equipment malfunctioned, forcing pilots to abort the mission and return to base. British radio sets had to be installed to replace the American equipment that proved incompatible with Royal Air Force ground stations. These teething troubles were perhaps inevitable given the rapid deployment of a new aircraft type, but they did nothing to improve the P-47's reputation among pilots who had been flying proven designs. The transition itself had been difficult for many American pilots, particularly those of the 4th Fighter Group who had previously served in the Royal Air Force's Eagle squadrons. These men had flown Spitfires, aircraft that embodied a completely different design philosophy. The Spitfire was light, responsive, elegant in its movements. Pilots felt directly connected to their aircraft, able to throw it through violent maneuvers with ease. The P-47 felt entirely different. At rest on the ground, it weighed nearly 13,000 pounds without fuel or ammunition. Fully loaded for combat operations, that weight increased to 17,500 pounds or more. A Messerschmitt Bf 109, the most common German fighter, weighed less than half that amount. The sheer mass of the American fighter meant it could not match the instantaneous response or the tight turning radius of lighter opponents. Yet this apparent disadvantage concealed fundamental strengths that would only become apparent through combat experience. The weight that made the P-47 seem sluggish at low speeds provided stability at high speeds and altitudes where lighter fighters became difficult to control. The massive airframe could absorb battle damage that would destroy smaller aircraft. The weight included armor plate protecting the pilot and critical systems, rather than being wasted mass. Every aspect of the design reflected careful consideration of what would actually matter in sustained combat operations, rather than in individual dogfights. Republic Aviation's factory on Long Island in New York State was producing these giants at rates that would have seemed impossible just years earlier. By the time of Blakesley's first victory, the Farmingdale plant was completing one complete P-47 fighter every 4 hours around the clock. Production continued to accelerate with each passing month as manufacturing processes were refined and supply chains optimized. The man responsible for the P-47's design, Alexander Kartveli, had emigrated from Georgia in the Caucasus region and brought with him perspectives that differed from those of American or British designers. His approach to fighter aircraft seemed almost crude to European engineers trained in traditions emphasizing efficiency and weight savings measured in grams. Kartveli instead pursued maximum capability through maximum power, accepting weight that would make other designers uncomfortable if it meant achieving performance goals. Colonel Hubert Zemke understood this philosophy better than most. He commanded the 56th Fighter Group, another American unit equipped with P-47s. His group had arrived in England during January of 1943, and by April was flying regular combat missions. The 56th would become unique among 8th Air Force fighter groups by flying P-47s exclusively throughout the entire war in Europe, never transitioning to other fighter types as most units eventually would. Under Zemke's leadership, the group would ultimately claim 674 aerial victories, establishing the P-47's credentials as a formidable combat aircraft despite its unconventional characteristics. The mathematics underlying the P-47's firepower were straightforward enough, though their implications took time to fully appreciate. Early models, the P-47C and initial P-47D variants, carried 350 rounds of ammunition for each of their 8 guns. That totaled 2,800 rounds stored in ammunition boxes within the wings. The guns themselves were positioned with 4 in each wing, carefully aligned so that their bullet streams would intersect at a specific distance. This convergence zone, typically set at 250 yards, created a space where all 8 guns' fire concentrated into a relatively small area. Any target within this zone faced the full destructive potential of the aircraft's armament. A pilot firing a 1-second burst would send 107 half-inch projectiles toward the target, each travelling at nearly 2,900 feet per second. The kinetic energy of this projectile stream was enormous, far exceeding what any single-engine fighter had previously delivered. The armour-piercing incendiary rounds could penetrate the armour plating carried by contemporary fighters and bombers, then ignite fuel tanks or ammunition stores. Even strikes against non-critical areas could cause sufficient structural damage to bring down an aircraft through the sheer volume of hits accumulated in seconds. German intelligence officers initially refused to believe reports describing the P-47's armament. 8 heavy machine guns on a single-seat fighter violated everything they understood about fighter design constraints. Weight, space, ammunition storage, recoil forces all suggested that such armament levels were technically infeasible. Surely Allied intelligence had made errors, or pilots had exaggerated what they faced. German fighter doctrine had evolved around very different principles, emphasizing the minimum armament necessary to reliably destroy enemy aircraft while conserving weight for performance and range. This efficiency-focused approach had produced excellent fighters carrying mixed armament of lighter machine guns and heavier cannons. The Focke-Wulf 190, which served as the Luftwaffe's primary fighter in Western Europe during spring 1943, typically carried 2 rifle-caliber machine guns with generous ammunition supplies and 2 20mm cannons with more limited ammunition. The machine guns, 7.92mm MG-17S, each had 1,000 rounds available. The cannons, MG 151/20S mounted in the wing roots, carried 250 rounds each. While the explosive shells fired by these cannons inflicted devastating damage when they hit, the limited ammunition supply meant German pilots had to be selective about when they fired. 500 cannon rounds total translated to approximately 15 to 20 seconds of firing time, and pilots typically fired in short bursts to conserve ammunition. German training emphasized marksmanship and ammunition conservation. Pilots learned to close to short range before firing, taking careful aim, firing precisely controlled bursts at optimal deflection angles. These techniques had worked well against British fighters, which typically carried 8 rifle-caliber machine guns or various combinations of machine guns, and cannons, all with ammunition supplies that required careful management. Neither side had previously encountered a single-seat fighter carrying what amounted to unlimited ammunition for practical combat purposes. Following that first victory on April 15th, encounters between P-47s and German fighters increased in frequency and intensity. 2 days later, on April 17th, P-47s of the 4th Fighter Group flew their first bomber escort mission, though limitations with early external fuel tank configurations forced them to turn back before reaching the bomber's maximum penetration into German-controlled territory. Despite this technical limitation, the mission demonstrated the P-47's potential role in the strategic air campaign. More importantly for German pilots, it provided their first experience with the psychological impact of facing the American fighters' overwhelming firepower. The visual effect created by 8 guns firing simultaneously proved profoundly disturbing to German pilots who had never encountered anything similar. The standard American ammunition loading pattern placed 1 tracer round for every 4 armor-piercing incendiary rounds. This meant that 1 out of every 5 projectiles burned brightly enough to be visible in daylight, creating the illusion of a continuous stream of light rather than individual bullets. German pilots accustomed to seeing occasional tracer rounds marking the path of cannon fire instead saw what appeared to be solid beams reaching out from the American fighters. The psychological effect of this visual display, combined with the knowledge that thousands of half-inch projectiles were filling the air, influenced tactical decisions in ways that would take months to fully appreciate. By May of 1943, the Luftwaffe's Testing and Evaluation Center at Rechlin was examining captured P-47 components in an effort to understand the American aircraft's capabilities and limitations. German engineers who inspected the Browning machine guns discovered that they were based on a design dating back to 1933, which seemed to confirm initial assumptions about American technical conservatism. However, closer examination revealed that these weapons had been refined through more than a decade of mass production to achieve unprecedented levels of reliability and manufacturing precision. Parts were truly interchangeable in ways that German weapons were not. Any component removed from any gun would fit perfectly into any other gun of the same type, eliminating the hand fitting and adjustment that German armaments required. The ammunition feed system employed disintegrating link belts that separated as rounds were fired, with the metal links ejecting from the aircraft, along with spent cartridge cases. German fighters used either drum magazines, which were limited to between 60 and 200 rounds, depending on the weapon, or belt feed systems that retained the connecting links, adding unnecessary weight and creating potential sources of jamming. The American system's reliability meant that pilots could, if necessary, fire their entire ammunition load in one continuous burst without significant risk of malfunction. German pilots faced the constant possibility that their weapons might jam after sustained firing, particularly with the cannons, which were more complex and temperamental than machine guns. The scale of American ammunition production stunned German analysts, who eventually gained access to intelligence about Allied industrial capabilities. By mid-1943, the 8th Air Force was conducting more than 200 P-47 sorties every day on average. Each aircraft carried 2,800 rounds. Pilots typically expended approximately 60% of their ammunition during a combat mission, whether in actual combat or in ground attack. These figures meant that American fighters were firing approximately 336,000 rounds daily, a number that exceeded the total weekly allocation for all German fighter units stationed in France. The implications of this production disparity were staggering when fully appreciated. A single American ammunition plant, the Lake City Army Ammunition Facility in Missouri, had reached production capacity of 1.6 billion rounds annually by 1943. This one facility outproduced Germany's entire small arms ammunition industry across all calibers. The plant operated continuously with 20,000 workers divided into multiple shifts, maintaining quality control standards that rejected any ammunition varying more than 1,000th of an inch from specifications. Workers, predominantly women by this point in the war, inspected every round multiple times before it was packaged for shipment. The result was ammunition of consistent quality that functioned reliably even in the extreme conditions found at high altitude where temperatures dropped to 60 degrees below 0 Fahrenheit. Republic Aviation's production capabilities expanded throughout 1943. The original Farmingdale plant covered more than 765,000 square feet of manufacturing space. A second production line opened in Evansville, Indiana, adding substantial additional capacity. Combined output from both facilities exceeded 400 complete P-47 fighters every month by late 1943, with production continuing to increase. Meanwhile, German fighter production of all types struggled to exceed 1,000 aircraft monthly, despite desperate efforts to expand manufacturing capacity. The resource allocation required to achieve these production rates revealed fundamental differences between American and German approaches to industrial warfare. German fighter doctrine continued to emphasize lightweight, highly maneuverable aircraft that could be produced in quantity while using relatively limited resources. The Messerschmitt Bf 109 G6, the most common German fighter variant by mid-1943, weighed 6,940 pounds fully loaded for combat. The Focke-Wulf 190A-5 reached 9,040 pounds. These weights seemed appropriate for single-seat fighters based on decades of design evolution. The P-47C weighed 13,500 pounds loaded. The improved P-47D reached 14,500 pounds. Such weight seemed impossibly excessive by German standards, suggesting an aircraft that would be dangerously sluggish in combat. Yet the P-47's enormous Pratt & Whitney R2800 double Wasp engine produced sufficient power to overcome this weight penalty. Initial models generated 2,000 horsepower. Later variants produced 2,300 horsepower through water injection systems and other refinements. The resulting power-to-weight ratios, while not matching the lightest fighters, proved entirely adequate for combat operations. Moreover, the weight provided significant advantages that lighter fighters could not match. The P-47 was rock solid as a gun platform, its mass dampening the recoil from 8 machine guns firing simultaneously. It could absorb battle damage that would destroy lighter aircraft, with armor plating and redundant systems protecting pilot and critical components. The General Electric turbo supercharger system alone weighed 845 pounds, nearly as much as the entire armament of many German fighters. This complex system routed exhaust gases from the engine to spin a turbine that compressed incoming air, maintaining sea-level air pressure at the engine intake even at extreme altitudes. The weight penalty seemed enormous, but the performance benefits proved decisive. While the BMW 801 radial engine powering the FW190 lost significant power above 20,000 feet altitude, the P-47's R2800 maintained full power at 30,000 feet. This altitude advantage meant P-47s could attack from above at speeds where German fighters struggled to respond effectively. The shock of encountering P-47 firepower forced the Luftwaffe to develop new tactical approaches almost immediately. Traditional attack methods, which had worked well against British fighters, became suicidal when P-47s were present. German fighters had typically exploited superior maneuverability to achieve advantageous firing positions, closing to short range before firing carefully aimed bursts. Against P-47s, this approach meant flying through fields of fire where thousands of half-inch projectiles filled the air. American pilots did not need perfect firing solutions. Their volume of fire created kill zones that German fighters could not safely traverse. Luftwaffe units began emphasizing the FW190's superior roll rate and turning performance at low altitude, attempting to draw American fighters into circumstances where German advantages would tell. However, reaching low altitude required diving through the altitude bands where P-47s held advantages, exposing German fighters to attack during their descent. American pilots learned to exploit their altitude advantage and firepower superiority to force German fighters into unfavorable positions. Rather than pursuing Germans into turning fights at low altitude, Americans could climb back to altitude and wait for another advantageous engagement. The contrast in ammunition philosophy created fundamental tactical differences that influenced every aspect of air combat. German pilots entered combat knowing they had between 60 and 90 seconds of firing time available before their ammunition was exhausted. Every burst had to count. Missing meant wasting irreplaceable ammunition. P-47 pilots had 30 to 35 seconds of continuous fire available, which translated to far more effective engagement time because they could fire longer bursts without concern about ammunition exhaustion. This disparity fundamentally altered the nature of air combat. Germans had to conserve ammunition while Americans could fire liberally, using ammunition expenditure to compensate for less precise aim. The mission to Schweinfurt and Regensburg on August 17, 1943, demonstrated both P-47 capabilities and their significant limitations with painful clarity. Within the range where P-47s could provide escort, they devastated German interceptors attempting to reach the bomber formations. The 56th Fighter Group alone claimed 17 aerial victories without suffering any losses of their own. American pilots were learning to exploit their aircraft's strengths effectively, using altitude advantage and overwhelming firepower to break up German attacks before they could develop into serious threats. However, P-47s lacked the range to escort bombers to these distant targets and back. Fuel exhaustion forced escorts to turn back, leaving bombers vulnerable to concentrated German attacks. German controllers had quickly learned to monitor American fighter operations carefully, calculating when escort fighters would reach their fuel exhaustion points and be forced to withdraw. Beyond escort range, German fighters operated freely, inflicting devastating losses on unescorted bomber formations. The solution required extending P-47 range through external fuel tanks. Initial drop tank designs were problematic, prone to failures that left aircraft without needed fuel. Progressive improvements introduced larger tanks and better systems. 108-gallon tanks came first, followed by 150-gallon tanks that significantly extended range. By October 1943, P-47s could escort bombers to targets 425 miles from their bases, deep into German-controlled territory. Each extension of escort range forced German fighters to wait longer and fly farther before they could engage bomber formations without facing American escorts. The protective umbrella that P-47s provided expanded steadily, pushing the air battles farther from Allied bases and closer to German airfields. German fighters had to take off earlier, climb to altitude over longer distances, manage fuel consumption carefully while waiting for American escorts to depart. All of these factors favored the Americans, who could operate with far less concern about fuel management thanks to their enormous internal fuel capacity and reliable external tanks. The infrastructure supporting P-47 operations reached scales that German forces simply could not comprehend. Each P-47 squadron maintained reserves of 500,000 rounds of ammunition. Forward airfields across England stockpiled millions of rounds at hardened storage facilities. Supply ships delivered fresh ammunition continuously from American factories, crossing the Atlantic in convoys that German submarines could no longer effectively interdict. A typical P-47 group possessed enough ammunition for 30 days of maximum intensity operations without receiving any resupply whatsoever. This abundance meant pilots never worried about ammunition availability, never had to conserve rounds for some hypothetical future engagement. German fighter units operated on 3-day ammunition reserves under optimal conditions, often less when supply lines were disrupted. American pilots fired liberally, hosing down targets with sustained bursts. German pilots counted every round, knowing that once their limited ammunition was exhausted, they would be defenseless. The contrast extended to every aspect of operations. American depots maintained complete replacement engines, entire gun sets, major structural components. A damaged P-47 could be completely rebuilt from spare parts in a matter of days. German units cannibalized damaged aircraft for parts, reducing operational strength even when enough airframes theoretically existed. Black Thursday, October 14, 1943, the second Schweinfurt raid, marked a crucial turning point in the air campaign. P-47s flew escort to their maximum possible range, claiming 21 German fighters during the mission. However, bombers still faced devastating attacks once escorts departed, suffering catastrophic losses that forced a temporary halt to deep penetration missions. Despite this tactical defeat for the bombers, German pilot reports from the engagement revealed growing concern about engaging P-47s. The mathematics were becoming irrefutable to anyone paying attention. A German fighter squadron called a Staffel typically consisted of 12 aircraft when at full strength. These 12 fighters might collectively possess 7,000 rounds of ammunition total, combining all calibers carried. A single American P-47 squadron of 16 aircraft carried 44,800 rounds of heavy machine gun ammunition, with millions more available in reserve at their base. The firepower advantage was staggering, and it was amplified by dramatic differences in pilot training that were becoming increasingly apparent. American P-47 pilots typically arrived at combat units with more than 400 hours of total flight time. This included approximately 100 hours devoted specifically to air-to-air gunnery training against towed targets and ground targets. They had fired thousands upon thousands of practice rounds before ever encountering an enemy aircraft. They understood ballistics, deflection shooting, convergence zones. They knew their weapons intimately. German pilot training by late 1943 averaged 110 hours total flight time before combat assignment. Perhaps 20 hours of that time involved gunnery training. Fuel shortages across Germany meant many pilots entered combat having fired their aircraft's guns only a handful of times during training. The training disparity meant German pilots faced American opponents who had expended more ammunition during peacetime training than many German pilots would fire throughout their entire combat careers. Lieutenant Colonel Francis Gabreski, who would become the leading P-47 ace in Europe with 28 confirmed aerial victories, described the tactical reality simply and directly. American pilots did not need to be better shots than German pilots. They needed to place their gun sight on the enemy aircraft and hold the firing button down. The 850 caliber guns did the rest. Volume of fire compensated for imperfect aim. Sustained bursts guaranteed hits even against maneuvering targets. By November 1943, P-47 groups began dedicating increasing effort to ground attack missions after completing bomber escort duties. The 50 caliber guns proved devastatingly effective against locomotives, vehicles, and aircraft parked on German airfields. Armor-piercing incendiary ammunition could penetrate locomotive boilers, puncture vehicle fuel tanks, ignite ammunition stores. A single P-47 could destroy an entire train in one attack pass, permanently removing critical transportation assets from the German war machine. The standard attack profile involved entering a 30-degree dive, opening fire at 1,000 yards distance, walking the rudder pedals to spray bullets across a wide area as the aircraft closed on the target, then pulling out of the dive at 200 yards to avoid ground fire. In approximately 10 seconds, a P-47 could deliver between 800 and 1,000 rounds into a target area 100 yards long. The physical destruction was impressive enough, but the broader strategic impact proved even more significant. German transportation networks faced systematic destruction. P-47s destroyed locomotives faster than German industry could possibly replace them. Rail cars were shredded. Stations were shot up. By December 1943, German military units avoided rail movement during daylight hours due to the near certainty of air attack. This forced reliance on slower road transport and nighttime rail movement, drastically reducing the mobility that German forces had relied upon during earlier campaigns. The P-47's role in the strategic bombing campaign proved absolutely crucial during this transitional period. While the P-51 Mustang would eventually assume the long-range escort role thanks to its superior range when equipped with external tanks, P-47s provided the initial shield that allowed the bomber offensive to continue despite the heavy losses suffered during 1943. Without effective escort, the daylight bombing campaign would have been unsustainable. P-47s made it possible for bomber formations to reach targets, inflict damage, and return with acceptable loss rates. This maintained pressure on German industry and forced Germany to dedicate enormous resources to air defense rather than front-line combat. By early 1944, improved P-47D variants carried 425 rounds per gun, increasing total ammunition capacity to 3,400 rounds. Later models would carry even more. These increases extended effective combat time and allowed pilots to engage multiple targets during a single mission. Range improvements continued as well, with internal fuel capacity increasing and external tank systems becoming more reliable. The P-47M variant, developed specifically to counter German jet fighters, achieved speeds exceeding 460 miles per hour at altitude. The P-47N, designed for Pacific operations, carried 550 gallons of internal fuel, a staggering capacity that exceeded the fuel loads of many German medium bombers. June 6, 1944, D-Day, the Allied invasion of Normandy, provided the ultimate demonstration of what P-47s had achieved. American fighters flew 2,398 sorties over the invasion beaches and inland areas. They claimed 84 German aircraft destroyed in aerial combat and another 89 destroyed on the ground. More significantly, they effectively paralyzed German ground movement through sustained interdiction attacks. The Luftwaffe managed only 319 sorties over Normandy on this crucial day. The Americans flew more than 13,000 sorties total. German fighters across the entire Normandy sector possessed perhaps 200,000 rounds of ammunition combined. American fighters carried millions of rounds with essentially unlimited resupply capability from bases in England. P-47S created free fire zones across Normandy, where anything moving during daylight hours was destroyed. German vehicle columns attempting to reach the invasion beaches were reduced to burning wreckage in single attack passes. The distinctive whistling sound produced by P-47s diving at high speed, caused by air flowing through gun ports and engine cooling ducts, became a terror weapon in its own right. German soldiers learned to recognize the sound and dive for cover, even when they were not the intended target. The psychological effect of this constant air threat had strategic implications that extended far beyond the physical destruction inflicted. By late 1944, German fighter production actually peaked at approximately 25,000 aircraft annually, an impressive achievement given the sustained bombing campaign against German industry and the deteriorating resource situation. However, severe fuel shortages, catastrophic pilot losses, and overwhelming Allied numerical superiority meant that most of these newly manufactured aircraft never flew operationally. Those that did manage to reach combat units faced odds routinely exceeding 10 to 1. Experienced Luftwaffe pilots were dead or prisoners. Replacement pilots arrived at units with minimal training and faced American pilots who were veterans of dozens or hundreds of combat missions. The Messerschmitt Me-262 jet fighter provided a dramatic speed advantage, but not firepower superiority. Its 430mm Mk-108 cannons carried only 80 to 100 rounds per gun, totaling just 360 rounds. While the massive explosive shells were devastating against bomber formations, the limited ammunition and low muzzle velocity made them less effective against agile fighter opponents. Moreover, Me-262s were vulnerable during takeoff and landing, when their speed advantage disappeared. American fighters learned to patrol near known jet bases, attacking Me-262s during their most vulnerable moments. Final production statistics tell a story of industrial dominance that translated directly into battlefield success. Total P-47 production reached 15,683 aircraft from all sources. Peak monthly production exceeded 400 aircraft from combined manufacturing facilities. Total FW-190 production, including all variants from 1941 to 1945, reached approximately 20,000 aircraft. Fighter variants specifically numbered around 13,000. Each American P-47 was fully equipped with 8 guns and adequate ammunition supplies. German fighters increasingly flew with reduced armament configurations due to material shortages. By 1945, some FW-19s operated with only 2 cannons instead of the standard 4, an attempt to conserve scarce ammunition and materials. Republic Aviation's manufacturing facilities eventually covered more than 1 million square feet of production space dedicated to P-47 production. German fighter production operated from facilities that were frequently bombed, forcing dispersal of manufacturing into smaller shops that reduced overall efficiency. The Lake City ammunition plant alone produced more than 1.5 billion rounds of .50 caliber ammunition annually. Combined with other American facilities, including Frankfurt Arsenal, Des Moines Ordnance Plant, and Twin Cities Ordnance Plant, total production exceeded 10 billion rounds of .50 caliber ammunition during the war years. German ammunition production for all aircraft weapons combined, encompassing every caliber from rifle-caliber machine guns to 30mm cannons, totaled approximately 4 billion rounds. Americans produced more rounds of their single standard heavy machine gun caliber than Germany produced of all aircraft ammunition types combined. This staggering disparity reflected fundamental differences in industrial capacity, resource allocation, and strategic priorities. Quality control revealed similar disparities. American ammunition underwent multiple inspection stages with rejection rates between 2 and 3% for quality failures. German production, increasingly dependent on forced laborers and substitute materials as the war progressed, experienced higher malfunction rates that reduced effective firepower in combat. The United States Strategic Bombing Survey conducted extensive analysis of air operations in Europe after the war concluded. Their documentation of P-47 achievements provided comprehensive data. 3,916 enemy aircraft destroyed in aerial combat. 3,202 enemy aircraft destroyed on the ground during airfield attacks. 9,000 locomotives destroyed, permanently removing critical transportation capacity. 86,000 railway cars destroyed. 68,000 motor vehicles destroyed. 6,000 armoured fighting vehicles destroyed, including tanks and self-propelled guns. These statistics represented strategic impact far exceeding tactical success in individual engagements. The destruction of transportation infrastructure by P-47s significantly reduced Wehrmacht mobility and logistics capabilities. German ground forces increasingly found themselves unable to concentrate forces effectively or maintain supply lines under constant air attack. The Luftwaffe's inability to counter P-47 ground attacks meant American air power operated with near impunity across Western Europe once air superiority was achieved. This freedom of action allowed the extension of air operations deep into German-controlled territory, attacking targets that had previously been beyond effective reach. American pilots who completed their combat tours, initially set at 25 missions, later extended to 35 and eventually 50 missions, rotated home to train new pilots, spreading combat experience throughout the training system. German pilots flew continuously until they were killed, captured, or physically incapacitated. By late 1944, most Luftwaffe pilots were inexperienced novices facing American veterans with hundreds of combat hours. The experience gap widened continuously as German losses mounted and American training programs incorporated combat lessons with minimal delay. American training programs evolved rapidly based on combat reports from Europe. Successful tactics were analyzed, codified, and taught to new pilots before they deployed overseas. German training, increasingly disrupted by fuel shortages and abbreviated by desperate necessity, produced pilots with wildly varying skill levels who lacked the standardized tactical training that characterized American operations. This meant American formations operated with predictable cohesion, while German units struggled to maintain coordination. Beyond pure firepower, P-47s incorporated numerous technologies that enhanced overall combat effectiveness. The turbocharger allowed full power at extreme altitudes where most piston engines struggled. The R2800 engine's legendary reliability meant consistent performance with overhaul intervals of 400 hours under normal conditions. The K-14 computing gun sight, introduced in late 1944, automatically calculated deflection using gyroscopic principles. Pilots simply framed their target within the sight reticle and fired. The sight adjusted automatically for aircraft speed, target speed, and deflection angle. German fighters used reflector sights that required pilots to manually estimate deflection, a skill that required extensive practice to master. Gun heating systems prevented the freezing problems that plagued many aircraft operating at extreme altitude. P-47 guns functioned reliably at 40,000 feet in temperatures of 60 degrees below 0 Fahrenheit. German fighters frequently experienced gun malfunctions above 25,000 feet, particularly with wing-mounted weapons that were exposed to the extreme cold without adequate heating. This reliability advantage meant P-47s could engage effectively at altitudes where German fighters struggled with mechanical problems. American maintenance advantages extended throughout operations. P-47 groups maintained extensive inventories of spare parts, including complete engines, gun sets, propellers, and major structural components. Ground crews could completely replace an engine overnight when necessary. Battle damage that would require weeks of repair work for German units could be fixed in days by American maintenance personnel. German maintenance capabilities became increasingly problematic as the war continued. Spare parts shortages meant extensive cannibalization of damaged aircraft. By late 1944, Luftwaffe serviceability rates dropped below 50%. American P-47 groups routinely maintained 85% serviceability, ensuring maximum aircraft availability for operations. American crew chiefs were trained specialists with extensive technical education. They understood their aircraft thoroughly and could diagnose problems quickly. German ground crews, severely depleted by conscription demands, increasingly consisted of foreign workers and Hitler Youth members with minimal technical training. This reduced the effectiveness of maintenance efforts and increased the time required to repair battle damage or mechanical failures. Skilled German mechanics were spread too thin across too many units, unable to provide the concentrated expertise that American units enjoyed. P-47s burned 100/130 octane aviation fuel, a high-quality product that allowed higher engine manifold pressures and consequently increased power output. German synthetic fuel produced from coal through the Fischer-Tropsch process provided inconsistent octane ratings that reduced engine performance and reliability. By late 1944, fuel shortages were so severe that German fighters received between 30 and 50 gallons per sortie when fuel was available at all. P-47s routinely carried 370 gallons internally plus external tanks when needed. American pilots could fly multiple missions per day, while German pilots sat grounded by fuel shortages. German pilots understood that aggressive maneuvering consumed precious fuel they needed for return flights to base. This created a psychological burden that influenced tactical decisions. American pilots flew without fuel anxiety, free to maneuver as needed to achieve advantageous positions. This fundamental difference in operational freedom influenced outcomes in ways difficult to quantify but nonetheless significant. The fundamental contrast between American and German approaches could not have been clearer. Where Germans pursued technical perfection in limited quantities, Americans pursued adequate performance in unlimited quantities. Kartvel's P-47 design prioritized manufacturability over optimization. The aircraft was actually easier to manufacture than many German fighters despite its greater size and complexity. Standardization and mass production techniques meant faster production at lower per-unit cost. This philosophy extended throughout the American supply chain. The same 50 caliber ammunition fired by P-47s was used by bombers, ground vehicles, and naval vessels. This commonality simplified logistics while achieving economies of scale impossible with diverse specialized calibers. German forces used dozens of different ammunition types across their various weapons systems, each requiring separate production and distribution. The inefficiency was enormous compared to American standardization. German attempts to match American firepower proved futile and counterproductive. The FW-190A-8, introduced in February 1944, could carry additional cannons in underwing pods for bomber interception missions. However, the added weight and drag severely degraded flight performance, making these heavily armed aircraft vulnerable to escort fighters. The Sturmjäger variant, optimized specifically for bomber destruction with heavy armor and 30mm cannons, was virtually helpless against American escort fighters. These specialized variants represented desperate attempts to counter specific threats, but created new vulnerabilities in the process. The fundamental problem facing Germany was industrial capacity. The nation simply could not simultaneously fight a multi-front war and match American production across all categories. Attempting to do so only accelerated the exhaustion of resources that were already inadequate. Every choice involved painful trade-offs. Resources devoted to fighter production were unavailable for tanks. Resources devoted to ammunition production were unavailable for fuel production. The Germans were fighting an industrial war with an industrial base far too small for their strategic requirements. Beyond physical destruction, P-47s achieved psychological victories that undermined German combat effectiveness. The distinctive whistling sound of diving P-47s became a terror weapon, producing persistent anxiety among German soldiers. They developed Pavlovian responses to aircraft sounds, diving for cover even when aircraft were not directly threatening them. This constant stress degraded combat effectiveness and morale. American pilots understood and exploited their psychological advantage. They flew with confidence born from unlimited resources and superior training. German pilots flew with desperation born from scarcity and inadequate preparation. Mental states influenced tactical decisions in subtle but significant ways, with Germans increasingly avoiding combat unless absolutely necessary. The P-47 achieved a kill ratio of 4.6 to 1 over its combat career, encompassing more than 746,000 sorties. Approximately 3,000 P-47s were lost to all causes combined, representing less than 0.5% loss rate per sortie. German fighter units by late 1944 suffered 50% monthly casualty rates, unsustainable attrition that destroyed unit cohesion and eliminated experienced leadership. The 56th Fighter Group, flying only P-47s throughout the war, became the top-scoring American fighter group in Europe with 674 confirmed aerial victories. This achievement demonstrated that supposed P-47 limitations could be overcome through proper tactics, superior training, and overwhelming material support. The P-47's 850 caliber guns represented far more than firepower in isolation. They embodied a complete industrial philosophy triumphant. Each gun required precision manufacturing with tolerances measured in thousandths of inches. Supply chains had to deliver thousands of components to assembly facilities. Workers had to maintain quality while achieving unprecedented production rates. That America could mount 8 such weapons on every fighter with ammunition sufficient to sustain continuous operations demonstrated industrial supremacy transcending simple military calculations. Military historians recognize P-47 firepower as decisively important in achieving air superiority over Europe. The ability to deliver overwhelming firepower at extended ranges broke the Luftwaffe's defensive capabilities systematically. Once air superiority was firmly established, Allied victory became inevitable regardless of other factors. German ground forces could not maneuver effectively under constant air attack. German industry could not operate efficiently under sustained bombing. German logistics could not function with transportation networks under continuous interdiction. The P-47's influence extended far beyond World War II into modern air combat doctrine. It established principles that continue dominating fighter design and employment. Firepower superiority through volume of fire remains fundamental. Standardization enabling mass production is accepted without question. Industrial capacity determining military capability is understood as basic reality. Modern fighters carrying rotary cannons firing 6,000 rounds per minute are direct descendants of the P-47's philosophy. Precision-guided munitions represent evolution rather than rejection of the firepower principle. Another manifestation of overwhelming force delivered through industrial superiority. When West Germany rebuilt its air force during the 1950s, it adopted American equipment, tactics, and doctrine wholesale. German pilots trained on American aircraft, fired American ammunition, absorbed American philosophy completely. The student had learned from the master, accepting that their earlier approaches had proven inadequate against industrial warfare's realities. This philosophical shift represented perhaps the most significant victory, the recognition that combat effectiveness derived more from industrial strength than from individual skill or tactical cleverness. Individual accounts reveal the human dimension behind statistical summaries. Colonel Robert S. Johnson of the 56th Fighter Group survived an attack on June 26, 1943, that put more than 200 bullet and cannon holes in his P-47. The aircraft absorbed damage sufficient to destroy any German fighter multiple times over, yet flew home with partial control surfaces and shattered canopy. Johnson landed safely and the aircraft was repaired and returned to service. This incident demonstrated the survivability that weight and robust construction provided, advantages that saved countless American lives. Colonel Hubert Zemke developed innovative tactics specifically designed to maximize P-47 advantages while minimizing exposure to German strengths. His Zemke fans spread squadrons across wide frontage, creating overlapping fields of fire that German fighters could not penetrate without severe casualties. Under his leadership, the 56th achieved remarkable success, flying P-47s exclusively, while other groups transitioned to longer-ranged fighters. Zemke proved that proper tactical employment could overcome any inherent aircraft limitations. German pilot Heinz Knoke, author of the memoir I Flew for the Führer, described encounters with P-47s as confronting streams of tracers so dense they appeared solid, making approaches to bomber formations effectively impossible when escorts were present. His memoir provides valuable perspective from the receiving end of American firepower, revealing the psychological impact on German aviators who faced overwhelming material disadvantage while knowing their situation could only deteriorate further. Behind all statistics stood millions of American workers producing the arsenal of democracy. At Republic Aviation's Farmingdale plant, women comprised 40% of the workforce by 1943. These workers built P-47s with precision exceeding peacetime manufacturing standards while maintaining production rates considered impossible just years earlier. Their dedication and skill translated directly into aircraft quality and pilot survival rates. Lake City Ammunition Plant operated continuously with workers producing billions of rounds in climate-controlled facilities. Quality control inspectors, predominantly women, rejected ammunition that failed to meet specifications regardless of production pressures. Their commitment ensured American pilots never experienced the ammunition failures that plagued German forces. American workers earned good wages relative to prevailing standards, lived comfortably with adequate food and housing, and took genuine pride in their contributions to the war effort. German production increasingly depended on forced labourers working in deteriorating conditions, resulting in sabotage and steadily declining quality. The contrast in worker motivation and conditions influenced product quality in ways that affected combat outcomes directly. American ammunition functioned reliably. German ammunition experienced increasing failure rates as quality control collapsed under pressure. The P-47 program cost approximately $1.3 billion in 1940s currency. This represented massive investment in a single weapon system. Yet American industrial capacity made this expenditure affordable, while simultaneously producing thousands of other aircraft types, tens of thousands of tanks, millions of vehicles, and enormous naval fleets. American mass production reduced unit costs continuously throughout the war. Early P-47s cost over $100,000 each. By 1945, unit costs had dropped to $83,000, despite numerous improvements that increased capability. German fighter costs increased throughout the war as production dispersal and material shortages reduced manufacturing efficiency. Post-war analysis revealed enormous gulfs between American and German production methods. American factories employed specialized machine tools, assembly line production, and statistical quality control. German production retained craft methods unsuitable for mass production at scale. The Browning M2's design facilitated mass production through simple, robust components that semi-skilled workers could manufacture using automated machinery. German weapons required skilled craftsmen using traditional hand-fitting methods. This fundamental difference meant America could expand production exponentially while Germany could not. The P-47's 8 guns represented synthesis of every American advantage working in concert. Industrial capacity provided the foundation through ability to produce fighters, guns, and ammunition in vast quantities. Technology enabled effectiveness through turbocharging, reliable engines, and precision manufacturing. Logistics delivered materials where needed when needed. Training ensured pilots could fully exploit technological advantages. No single element was decisively important in isolation. Their combination proved overwhelming against opponents lacking equivalent integration. Germany possessed excellent pilots, innovative technology, and tactical sophistication throughout the war. However, without adequate industrial foundation to support these advantages, they proved insufficient against American material superiority. The Luftwaffe was defeated not through superior tactics or better pilots, but through overwhelming material advantage symbolized perfectly by 8 guns firing continuously without concern for ammunition expenditure. German pilots facing P-47 Thunderbolts learned harsh lessons about modern warfare. Their Focke-Wulf 19s, which were excellent fighters by any traditional standard, were overwhelmed by American firepower delivered through industrial mass production. 8 50-caliber machine guns supplied with unlimited ammunition represented entirely new warfare paradigms. The transformation from initial confidence through shock to final acceptance mirrored Germany's larger World War II experience. Initial tactical superiority based on innovation and skill crumbled against American mass production and material abundance. The P-47, initially dismissed by many as too heavy and unwieldy, proved that industrial might could overcome apparent tactical disadvantages. German pilots were stunned not merely by 8 guns firing simultaneously, but by everything those guns represented. They symbolized a nation capable of producing unlimited weapons, unlimited ammunition, and unlimited aircraft. The Focke-Wulf 190 might have been superior in traditional terms, but traditional terms had become obsolete. The P-47's 850 caliber guns rewrote air combat rules through industrial power. This legacy endures in every modern fighter, emphasizing firepower over elegance, every massive munitions expenditure, every industrial approach to military challenges. All trace intellectual lineage to the moment when German pilots first encountered 8 synchronized Browning machine guns and realized their entire understanding of air combat had become obsolete. The P-47 Thunderbolt did not merely outgun the Focke-Wulf 190. It outproduced, outsupplied, and ultimately outthought German aviation philosophy through overwhelming firepower delivered by industrial democracy. Those 8 guns were not merely weapons. They were messengers of American industrial might, each burst demonstrating production capabilities that Nazi Germany could never match regardless of desperation or effort.